Welcome to another Mathnificent Conversation featuring simplifying rational expressions. It's your nerdy math bestie Lex. Grab your pencils and let's go. Before we get started simplifying, we're going to go over a little bit of background information, which I call mint green tea. First, simplifying rational expressions follows the same rules as simplifying fractions. It's the same concept, it's the same procedure, there are just variables involved. A rational expression is completely simplified when the numerator and denominator are relatively prime, just like with fractions. Relatively prime means the only common factor they share is 1. The steps are exactly the same as simplifying fractions. Factor both the numerator and the denominator completely. Simplify the common factors to 1. The one difference: if a factor simplifies to 1, you must acknowledge it, and we'll do that by saying x cannot equal this number, and more on that once we get to the actual examples. But keep in mind, anytime something simplifies to 1, it needs to be acknowledged. Okay, let's go over common mistakes with simplifying rational expressions. I'm going to start addressing common mistakes as Turks and chaos. Only factors simplify to 1, terms do not. Remember in the simplifying fractions videos, I explained factors are multiplied, terms are added or subtracted. So if two things are separated by an addition or subtraction sign, they are terms. If two things are multiplied together, they are factors. So let's take a look over here. X squared plus 3x. These two things are terms, not factors. So it is illegal to try to cancel or simplify that 3x over 3x to 1. That is chaos, very illegal. On the right-hand side, we have 3x times x squared all over 3x. In between 3x and x squared is multiplication. When two things are next to each other, that's multiplication. So this 3x and that 3x does simplify to 1, and we're left with x squared. Same here, x plus 1 times x plus 2. X plus 1, this guy and this guy, these are factors because they are multiplied, which means the x plus 1 and the x plus 1 can simplify to 1, and we're left with x plus 2. Just keep in mind as you're working through the difference between a factor and a term. Okay, let's simplify 3x plus 3 all over x plus 1. Now, I'm going to start by saying you have to be good at factoring. If you're not good at factoring, please review the factoring videos. They're very helpful. But simplifying rational expressions requires you to be good at factoring. So at the top, I can see that both terms have a common factor of 3, and the greatest common factor is 3. So I'm going to factor that out. 3x divided by 3 is x. 3 divided by 3 is 1. The bottom is prime. X plus 1 cannot be factored at all. Okay, now both my numerator and my denominator have a common factor of x plus 1. So those simplify to 1, and we're left with 3. Now here's the important part. Just like with numbers, you cannot ever divide by 0. We don't divide by 0. So you have to make sure now that the x plus 1 is gone, you have to say x cannot equal -1, because if I sub in -1 plus 1 is 0, I would have ended up with 0 in the denominator. This is something we talk about being a part of a domain. That's a separate conversation. But anytime something simplifies out and now we can't see it, we need to say, make sure you know x cannot equal whatever would have made the denominator 0, which in this case is -1. Okay, let's simplify 2x plus 8 over x squared minus 16. All right, let's focus on the numerator. The numerator has a greatest common factor of 2. I can factor a 2 out. 2x divided by 2 is x. 8 divided by 2 is 4. So after factoring out 2, we're left with x plus 4. The bottom is a difference of 2 squares. X squared is a perfect square. 16 is a perfect square, and they're subtracted. And that factors to x minus 4, x plus 4. Both the numerator and denominator have a common factor of x plus 4, so they simplify to 1. We're left with 2 over x minus 4, acknowledging that x cannot equal -4, because -4 would have made the denominator 0 before the common factors simplified to 1. Okay, let's simplify x squared minus 1 over x squared minus 5x plus 4. Notice everything right now is a term. I don't have any factors. Now we're going to factor both the numerator and the denominator. The numerator is a difference of 2 squares. It factors to x minus 1, x plus 1. The denominator is a quadratic trinomial. A equal to 1, so we just need 2 numbers that multiply to 4, but add to -5. So that's going to be -4 and -1. The numerator and the denominator both have a common factor, x minus 1. So we're left with x plus 1 all over x minus 4, both which are prime, so we can't factor them. Acknowledging that x cannot equal +1 because 1 would have made the denominator 0 before our common factors simplified to 1. Okay, let's simplify 9 minus x squared all over x squared plus 2x minus 15. Everything right now, we have all terms. We don't have any factors, so we're going to factor the numerator and the denominator. The numerator is a difference of 2 squares. It's going to factor into 3 minus x, 3 plus x. The denominator is a quadratic trinomial, a equal to 1. So we need 2 numbers that multiply to -15, but add to +2. So that's going to be x plus 5, x minus 3. Now, when we first look at it, it doesn't look like we have any common factors. But let's zoom in on this guy right here. Okay. 3 minus x, I can rewrite by flipping the 2 numbers to -x plus 3. 3 is positive on the left, 3 is positive on the right. X is negative on the left, x is negative on the right. These 2 statements are equivalent. Then I can factor a -1 out. If we factor or divide a -1 out, everything just becomes the opposite. So -x becomes +x, +3 becomes -3. So that 3 minus x can be rewritten as -1 times x minus 3. Then we have 3 plus x, which you could rewrite as x plus 3, but I'll leave it as 3 plus x plus 5, x minus 3. Now my numerator and denominator both have a common factor, x minus 3. And we're left with negative 1 times 3 plus x all over x plus 5, acknowledging that x cannot equal positive 3 because 3 would have made the denominator 0 before the common factors simplified to 1. And just to stress the fact this was some multiple choice question, 3 plus x and x plus 3 are the same. So you could rewrite that factor just like that. Our next example, x cubed minus 64 over x squared minus 16. The numerator is a difference of 2 cubes. Again, you have to be able to spot which method you're going to have to use to factor. So you need to know your perfect cubes in your head. You need to know your perfect squares because you need to be able to recognize them. X cubed is a perfect cube. 64 is a perfect cube. We're subtracting, so we have a difference of 2 cubes. They are going to factor to x minus 4, x squared plus 4x plus 16. You haven't watched the difference in sum of 2 cubes. This guy right here is always prime. So you don't have to waste time trying to factor it. It's always going to be prime. The bottom is a difference of 2 squares. It's going to factor to x minus 4, x plus 4. Our numerator and denominator both have a common factor of x minus 4. So we're left with x squared plus 4x plus 16 all over x plus 4, acknowledging x cannot equal positive 4 because positive 4 would have made the denominator 0 before the common factors simplified to 1. Our next example, let's simplify x squared over x cubed plus 9x. So our numerator factors to x times x. Our denominator has a GCF. Both terms have at least one x, so we can factor out an x. X cubed divided by x is x squared. And 9x divided by x is 9. X divided by x, both our numerator and denominator have a common factor of x, so that simplifies to 1. And that leaves us with x over x squared plus 9. Remember, there is not a sum of 2 squares. A sum of 2 squares is prime. It cannot be factored. This guy here is prime. So we leave it as is, but acknowledging x cannot equal 0 because before our common factor simplified to 1, 0 would have made the denominator 0, which is undefined. Okay, in our numerator, we have a quadratic trinomial with a equal to 1. And in our denominator, we have a quadratic trinomial with a greater than 1. We've done a few with a equal to 1. If you need a refresher on a greater than 1, there's a video for that, so make sure you check it out. A equal to 1 means we need two numbers that multiply to 7 but add to 8. So that's going to be x plus 1, x plus 7. I'm going to take the denominator and zoom in to do some scratch work. So first we do a times c, which is 2 times -7, -14. Two numbers that multiply to -14 but add to 13. It's going to be +14 and -1. Divide by a. A is 2. Divide by 2. This simplifies down to 7/1. Remember, bottom to top. This one is already simplified. X plus 7, 2x minus 1. 2x minus 1 times x plus 7. Both our numerator and denominator have a common factor, x plus 7. So we're left with x plus 1, which is prime, 2x minus 1, which is prime. We acknowledge x cannot equal -7. Okay, we've reached our last example in the simplifying rational expressions conversation. In our numerator, we have a sum of 2 cubes, 1 plus x cubed. I'm going to rewrite it as x cubed plus 1 so that I can flow with the sum of 2 cubes formula better. X plus 1, x squared minus x plus 1 all over 1 minus x. When I first look at it, it doesn't look like we have any common factors, but I'm going to zoom in on my denominator. 1 minus x can be rewritten -x plus 1. I can factor out a -1, and that leaves me with x minus 1. So now we have x plus 1, x squared minus x plus 1, which we know is prime, and -1 times x minus 1. We do not have a common factor between our numerator and our denominator. They are relatively prime. So we are finished. There's nothing that simplifies to 1. So we have factored it completely. We can't simplify anything out. So we stop. The numerator and denominator are relatively prime. Hope this conversation was helpful. Remember, you are magnificent, you are brilliant, and I'll see you in the next conversation.